Hello everyone, I'm here today to explain my regression machine learning model that I've built based on smart home energy optimization using IoT. I have built the classification model for the same problem statement, but today I'm building a regression model. So first we need to understand what is a regression. A regression is a fundamental concept in machine learning used to understand and model the relationship between the variables. So this means that it gives us the difference between the independent and the dependent variables, and it also means that it gives us the relationship between the input and the output. First, we need to import the libraries. As you can see, I have imported 4 libraries here. First one, import pandas as PD. I've used this to handle and manipulate the data set. Second one, sklearn.model underscore selection, import train underscore test underscore split. So I've used this for splitting the data, building models, and evaluating the performance. Third one, sklearn.ensemble. Ensemble model means that building hundreds of decision trees and choosing the better one based on the majority of vote. So I've imported random forest regressor here because I'm building a regression model. Now from sklearn.metrics, import mean squared error and R2 square. So for regression there are different metrics, and for classification there are different metrics. For classification I have used accuracy and confusion matrix, but for regression I have used mean square error and R2 score, but there are also other matrices I did use here. Now for the data set, data set I have loaded here is in CSV, so pd.read underscore CSV print data.head. This is used for printing the overview of the data set. Now as you can see, there are features in the data set like temperature, humidity, visibility, wind speed, and more. And now the target variable I have taken here is appliances, which has to represent the energy consumption. And there are more than 5 rows and 26 columns here, which you will see in the data set. Now target is equal to appliances. I have to prepare the data and separate the independent and the dependent variable. So I have given the name for a dependent variable. Appliances is the columns. I have given the name as target. I have to drop the dependent variable. So a dependent variable is that machine learns from this data and makes on this data set. So I have to drop this and in order to take the independent variables. So data.drop column is equal to target, and y I have taken the target as the dependent variable. Now in the next thing you see xtrain, xtest, ytrain, and ytest. For training purpose we use xtrain, and for testing purpose we use ytest. Now as I imported from the above train, test, and split, we have taken the independent variable, we have taken the dependent variable, and test size. So there is a common practice in machine learning to take 0.2, that is 80% of the data set for training and 20% of data set for testing. Now the random state. A random state is defined as making the values constant in the data set while performing the model. Now from sklearn.ensemble, import random forest regressor. For the classification we will use random forest classifier. For regressor we will use random forest regressor. Now I have given the RF model a name, a random forest regressor, and n estimator means that I have created hundreds of decision trees, and as you know, random forest is making the values constant. Now so I have to fit the model only in the training, and I have to make prediction in the test based on the fitted training model. So RF model dot fit in training, xtrain and ytrain, and prediction RF model dot predict in test. The model I have fitted here is being predicted on the testing model. Now the last one, random forest regressor performance. As I have told you, there are two matrices here, that is mean squared error and R2 square is also called as R squared. Now mean squared error means that it measures the average prediction error that a machine makes. So R squared error indicates how well the model explains the values that are varied in the data set. So as you can see, I have given as 0.2 Why I'm given it as 0.2 means it's formatting specifier. That means that it can take the value above after the decimal 2 points after the decimal. A format specifier is also called as print statement format specifier, that is used to control how numbers are displayed. That is that it gives a floating point we're displaying with 2 decimal places. So as you can see, there are 2 values points after the decimal. So that's all my model regression model is, and thank you.